All right, so we have a block with a mass m sliding down an inclined plane with an angle of 37 degrees. Block maintains a constant acceleration, 5.6 meters per second squared. So it is accelerating, and it's accelerating down the plane. They give you the sine and cosine of 37 degrees. Coefficient of kinetic friction between the block and the inclined surface is 0.05. So let's answer the questions now. Number 19, they're looking for a free body diagram. So the first thing we should do is draw a correct free body diagram here. So since it's accelerating down the plane, let's draw our x-axis in the same direction as the acceleration. And we also need a y-axis. All right, so there's our x and y axis. We know our, let's see, our weight. Our weight points straight down. So that's our weight. Let's call that mg. And we know theta is off of the y-axis. So theta is in here. What else do we have? We know that its normal force is perpendicular to the surface. That's normal force. And we have the mg component in the x direction would look like this, and that would be mg sine theta. And the weight component in the y-axis would be mg cosine theta. All right. So let's see. Going to number 19. We know that the weight always points straight down. So B doesn't look good. And E doesn't look good. And we know the normal force is always perpendicular to the surface it's sitting on. That's not perpendicular, and that's not perpendicular. So C would be your best bet here. 20, what's the normal force? Well, let's see. Normal force we can sum up in the y direction. Summation of forces in the y direction equals mass times acceleration in the y direction. Well, we know it's not accelerating in the y direction. So that's going to be 0. So we have Fn minus mg cosine theta equals 0, or Fn equals mg, equals 5 times 10 times the cosine of 37, which is 0.8. And it looks like we have 40 newtons. Number 21, what's the friction force between the block and the inclined plane? So we have friction force equals mu k Fn. And we know mu k in this case is 0.05. And Fn from the last one was 40. So 40 times 0.05, we're coming up with 2 newtons. Number 22, the coefficient of static friction between the block and the inclined plane is 0.4. Oh, and now we have 25 degrees. The block is placed on the inclined plane. What's the block going to do? So what we're attempting to figure out here is the force that's pulling it down the inclined plane. Is that force greater than the maximum static frictional force? So we would have a force pulling us back, and that's the static frictional force. And we have a force that's pulling us down the plane, which is that component of its weight in on the x-axis, so that would be mg sine theta. So the force of static friction, we can figure that out. So force of static friction equals mu k Fn, and mu k they give us is 0.4. Well, hang on, Fn, we have mu k, and Fn we said was equal to mg cosine theta, and mu k is 0.4 times 5 times 10 times cosine of 25 degrees. So we're getting the force of static friction equal to, oops, by the way, hang on. This is not mu k. This is mu s. And this is not 28 degrees anymore. This is 25 degrees. And now we multiply that out, we get 18 newtons. Mg sine theta, so that would be 5 times 10, which is 50, times the sine of 25 degrees, the sine of 25 degrees, sine 25 times 50, and we're getting sine 25. So we're getting the force moving it down the incline would be 21 newtons. So we have to ask ourselves, is 21 newtons greater than the force that's holding us back, which is 18? And obviously it is. So the box will move down the incline. It has a force moving it down the incline. So if there's a force moving it down the incline, it's going to accelerate, which means it has a change in its velocity. So C is start moving down the incline and continue to increase its velocity.